If I had to explain WWU Racing to someone who's never heard of it before, I would tell them that we're a team that builds, designs, and tests a Formula-style EV race car each year. But beyond that, we really operate like a small company, with our true goal being to build the next generation of industry professionals, both in engineering aspects as well as business aspects of the team.
When I look at what the team has built this year, to me it's the ultimate culmination of the biggest passion project I've ever had the fortune to work on. You'd think in a 2-year cycle a lot of people might lose motivation, but it's clearly not the case. No one's lost sight of the finish line. And to me that's really special to see.
On a team at the scale of WWU Racing, the students involved are very diverse and spread across the university, so we have a lot of students with different backgrounds and interests who come into the team, but because we're not the largest team on the grid, we get to really know our members and learn exactly what drives them.
What I want everyone to understand about this team and the students on it is that this is an A team, which makes my job as a director super easy. I never have to convince the team to buy into the goals they already are. Whenever we have big weeks of push, everyone's there to support each other. The desire to succeed that I see in every single member on the team is super inspiring.
What it looks like to build a Formula-style race car from scratch as college students is it means each year we get to design, manufacture, and then do on-track testing with our vehicle. It means total commitment and buy-in from everyone on the team working towards that single centralized goal. It takes all of this and to build a car like the one that you're going to see here today.
What do I want people to take away from being a part of the team? Well, FSAE is a place where you can just come to make mistakes, and that's what's so nice about it. People come in super eager to learn. You know, you can mess something up, you can teach other people about that mistake, and everyone grows because of it. You know, at the end of the day, FSAE is a place where you just learn to solve problems.
A team like this exists at a university because students ultimately want projects to work on. Students love to be able to take what they learn in class and apply it to things more than just the classroom space. And ultimately being in control of the thing that you're working on is something that's really unique, and I think is why FSAE teams crop up in universities. And overall, it's an opportunity to learn more hands-on than in a classroom environment. So getting to really harden those soft skills that, say, you learn about in school, but you don't really get to work on. And ultimately just getting to be on a team and being in charge of the things happening on that team is a really unique opportunity.
The culture I want this organization to continue forward into the future is one of being open to everybody who wishes to join the team. We've traditionally been a team that's open to anyone regardless of experience level, and I think that is an amazing opportunity for people. We are also a traditionally smaller team, so being able to give our team members more autonomy and ownership over projects is something I pride.
Hello, thank you guys all for coming out. I can't wait to show off Viking 67 for y'all today.
Great, so before we get started, just wanted to go through a quick agenda so you guys know what to expect today. We're going to introduce ourselves and our team, so if you don't know exactly what we have going on here, you'll get to meet exactly our team and what we do. And then we're going to talk more about competition that will be taking Viking 67 to this June. Additionally, we're going to talk about our season goals, which are the driving factors that made us build this car today. And then you're going to get to meet the subsystem leads, and they're going to get to talk about exactly what changed in their systems with the car that we have built today. We're going to reveal the car to you, and then afterwards we're going to have a social around the car where you're going to come up and ask any questions and get a closer look at the car, as well as learn more about systems that you're curious with. And then we'll do shop tours afterwards, so if you want to see the space that we work in, we'll be taking groups into our shop and letting you take a look around.
So if you don't know me, I'm Rob Petter. I am the project manager for our team, which is basically our team captain. So I'm responsible for the overall team, the team structure, its timeline, and its goals.
Hi all, my name is Jacob Spinello. I'm the technical director. I'm responsible for the design, manufacturing, and testing of Viking 67.
And I'm Ashley Bove. I'm the business director. I'm in charge of all of our business operations, ranging from our finances to event planning, as well as sponsor relationships and any internal operations.
So who is WWU Racing? If you don't know, we are a design and engineering team here at Western Washington University that is fully led and ran by students. So that's everything from our business and our management decisions down to all of our technical decisions and all of the parts we make on the car, like our custom space frame chassis, all of the carbon fiber components, and many of the aluminum CNC parts. Each year, our overarching goal is to develop industry-skilled professionals through the vessel of an FSAE EV car. We then take that car to Brooklyn, Michigan to compete in a series of both static and dynamic events against around 99 other teams. So the competition itself is an international competition. So teams come from all over, mostly the US, but we get teams from Canada, Mexico, South America, and some from over in Europe as well. We have to get through a rigorous technical inspection before we can take our car out on the track. Since this car is built by students, there's a lot of safety regulations that go into it that we need to be able to pass. After we do that, we have a series of static events. So these are events where we don't actually need our car, but we're presenting to a panel of judges and talking about our knowledge and how much we know. After that, we have our dynamic events, which is where we actually get to bring the car out on track. The first one is an acceleration, which is a 75-meter acceleration run. Then we have our skid pad, where they aim to evaluate our car's lateral performance. Then an autocross and endurance, which are both a cone-style race course, the endurance being a much longer version of the autocross.
Yeah, so for just a bit of background on our team, we switched to building electric vehicles in 2020, with Viking 67 being our fourth electric vehicle that we've built. And so behind building Viking 67, we really wanted to focus on our team and the community that we were building within our team. So specifically within the team, that was training up new members and really making sure we had an environment that new members felt safe and comfortable joining, where they knew they could learn more and really get involved with what we had going on. Additionally, we also wanted to work with better integrating ourselves into the community around our team. So we work out of the engineering department, so being able to better connect with the people in that department, not only the students that attend school there, but also the other clubs. So through our efforts, we were able to make a snack pantry for students who stay in the building after hours, and we ran pumpkin carving and various bridge building events with different clubs. We have worked really hard to stay connected with the department that surrounds us, and through these efforts with Viking 67, we almost doubled our team size. So for Viking 66's year, we had about 20 members, and now with Viking 67, we have about 40 full-time members.
So what are our goals? WWU Racing is a goal-oriented organization, and so at the highest level, we want to create a safe environment to foster personal growth through the vessel of an FSAE EV car and team. With that, the first is to build an inclusive culture. So we want everyone to be able to join the team regardless of background, regardless of financials, and especially regardless of experience level. So members are able to join having never worked on a car before, never used any of the engineering softwares that we used or any of the tools, and they're here and our leads are here to help them and train them up. With that, we also want to grow leadership skills, so we want our leads to have the ability to train up our newer members, invest that time into them to grow the team. As well, we want them to have these skills so that when they go out into industry, they're able to bring these skills there. Our third goal is more on the technical side, and that is to build a successful FSAE car. This year, we've defined that as a vehicle that passes technical inspection, completes all of the dynamic events at competition, and closes the engineering and design loop.
Yeah, so as Rice said, our successful car passes tech, completes all events, and closes the engineering loop, which is three things that we've never done since we've switched to EV. If we take a look at the past, Viking 63 was the first EV that we built, Viking 64 was the first EV that actually drove, and Viking 66 was the first EV to pass battery technical inspection. So you can see every single year that we're making improvements, but we hope that the 2-year cycle will allow us to do that last big jump and complete the rest of our goals. We have a really new exciting subsystem, data and simulations, to help us close that engineering loop and hopefully get this team back on track to being a team that engineers race cars, not just manufacturers race cars. With that, I'd like to invite the mechanical systems up on stage.
Nice.
Hello everyone, I'm Bryce Nisley. I'm the suspension lead for Viking 67. It's my 4th year on the team. These past few years I've had the pleasure of basically getting to redesign the suspension system from the ground up with the purpose of increasing the simplicity, decreasing the part count, and increasing the ease of manufacturing, as well as enabling a decreased steering effort and the packaging of a new smaller tire. To that end, we have this year all new upright packages, all new kinematics, as well as aluminum billet control arms, and the switch from a pull rod rocker actuated shock to a direct actuated shock. And all these changes have netted the system a decreased weight of over 20 pounds. Now let's hear from the drivetrain that makes these wheels spin.
Hello, I'm Eric Stenjum, and I am the drivetrain lead for Viking 67. This is my 3rd year on the team. So one of our main focuses with drivetrain this year is making a bunch of small changes to better work to passing our goals. So our main focus was on the cooling system. On Viking 66, we had a lot of issues with when we ran for an extended period of time. It would overheat and components weren't getting the flow rate that we designed. So we worked a lot with data and simulations to really fully understand our cooling loop and make an educated decision on sort of flow orientation, running them in parallel rather than in series. We also changed the drive ratio for the sprockets. That was done to account for our smaller wheel diameter. So, and in that, we redesigned our weight saving and was able to save about a pound out of the sprocket, as well as some changes to our radiator mounts and our inverter mount so that we can better accommodate high voltage cable routing. And with that, I'm going to pass it off to chassis, which holds everything else together.
Hi, my name is Jake Benjamin. I'm the Viking 67 chassis lead, and this is my 4th year on the team. So the chassis system is primarily responsible for the steel frame of the car. It's made of 66 tubes, and it comes in at 84 pounds, and it packages all the other components. Every tube we cut, cope, bend, and weld in-house, all by students, which we're really proud of. This year, to accomplish the team's primary goals of passing tech, our design changes were focused around making the chassis, pass tech as easily as possible. We also tried to improve packaging for other systems so that they could best accomplish their goal. So we redid the way that our pedals mount to the car when we worked with drivetrain, suspension, and high voltage to improve the packaging of their components as well. So for the chassis, this included stuff like redoing the nodes for the new suspension geometry. We're also responsible for ergonomic elements like the seat, the body panels, and the floor of the car. These are all made of carbon fiber, which we made in-house. Now I'll pass it off to brakes, pedals, and steering.
Hello everyone, my name is Jack Knight. I'm the brakes, pedals, and steering lead, more commonly known as Beeps, and this is my 3rd year on the team. So for a little context, our braking system that we've been running for the past 5 or so vehicles has been the same. And so it's a little outdated, so we started by making a brake force calculator to really understand how the brakes actually work and how to make a car stop. And so to do that entailed a lot of math, and that helped us understand what components to size the vehicle, so like what size master cylinders, what size rotors for the brakes, what size calipers. Using that data, we designed those new rotors up on board, and yeah. So the steering also got a full makeover. We switched from a U-jointed, shafted, segmented steering column to just a direct drive steering columm. It is much simpler, much easier to manufacture, much easier to take in and out of the car, and has been really useful. The pedals also got fully remade, where they before were on a full CNC billet mounting system, whereas now they're just directly mounted to the chassis, and it has made much simpler manufacture and easier to take in and out. And that's mechanical.
Next is our electronic systems.
Hello all, I'm Patrick Pearson, and I am the lead high voltage engineer for Viking 67, and this is my 4th year on the team. I'm responsible for the design and manufacturing of our tractive system high voltage battery pack. I want to start by telling you guys a little bit about our previous battery pack. So we utilized cylindrical 2170 cells in a 110 series 3 parallel configuration, meaning we had 330 total cells in our previous battery pack. That resulted in over 1,300 spot welds. Each one of those spot welds was a single point of failure. So this time around, we decided to move up to 14 amp hour Molesta pouch cells. Now this means that we only have 110 total cells, and in total 115 cell-to-cell connections. Each one of those connections is an order of magnitude less resistance, making our car a lot more efficient, and they are bolted, positively locked connection, making them a lot more vibration resistant as opposed to our previously spot welded connections. And again, on top of that, there's an entire order of magnitude less of those connections. With that, we also moved to an off-the-shelf Orion battery management system responsible for reading all of our cell voltages and temperatures within the tractive system battery pack. This system has been extremely plug and play and allowed us to focus on fine-tuning other aspects of the system. In total, this battery pack will be able to put out about 75 kilowatts or 100 horsepower at a peak with 50 kilowatt continuous discharge, and at a 6 kilowatt hour maximum capacity should be plenty of energy to get our drivers across the finish line. But again, none of this would be possible without the low voltage system keeping everything safe. So with that, I'll hand it off to Renee.
Hello everyone, my name is Renee, I'm the low voltage lead, and this is my third year on the team. So for a little bit of context, with Viking 66, we had a low voltage system that worked really well most of the time, but definitely had some reliability issues. So this year with Viking 67, we wanted to work to iron some of those out and create a really robust and serviceable system in support of our goals of passing technical inspection and completing all dynamic events. So this year we have 8 different student design printed circuit boards on the car that handle control and safety systems. For example, we have the vehicle control unit, which basically reads driver input from the pedals and outputs a requested torque to our motor. And we also have the low voltage breakout board that reads fault signals from the battery and basically shuts down the car if anything's going wrong. Over on the wiring harness side of things, we have over 100 critical signals that are carried throughout the harness that we need for the vehicle to function. And so this year we really focused on reliability of the harness, and we did that by implementing improvements such as service loops for strain relief and higher quality metal autosport connectors. Another big improvement we made this year is doing a full one-to-one CAD model of the wiring harness that allowed us to basically figure out all the wiring lengths ahead of time, lay up the wiring harness on a table in the fall, and save about 3 weeks of manufacturing time that we previously needed after the chassis was complete. So that really helped out with the whole team's timeline. So that's what's been going on with low voltage. Next, I'll pass it off to Con to talk about data and sims.
Hello, everyone. My name is Con Metalis, and I'm the data and simulations lead for V67. What we do is we calculate, simulate, and track test some of the designs on our car. And the main 2 subcategories that we broke that into this year were the vehicle dynamics and the thermal management. Starting off with the vehicle dynamics, it all starts with the tires. So by working with Bryce, the suspension lead, we were able to build a tire model, which is essentially where we take test data from the manufacturers, put it into the model, and we're able to predict our lateral and longitudinal grip capabilities. And with that, we're also able to simulate our car's performance in the dynamic events to get brake deceleration, acceleration in the acceleration event, and a whole bunch of just models that we want to make better the more we drive. So our methodology with that is just making them iterable. So the more we drive, the more data points we can put in, and the better we can make it. Second of which is the thermal management. So we tested our cooling system extensively with the drivetrain lead Erica. First of which is with the flow rate. So we iterated a bunch on the different ways in which our coolant can flow through the system and achieve the optimal flow rate based off of that iteration. And we also tested the heat sinks as well. So as you can see with our bench test setup, we ran coolant through the radiator and tested and got the heat dissipation rate. So with that gives us a design decision to tell us how much we'll get through the endurance event. And using the data logger, we're able to set up a bunch of sensors, set up test plans, and overall aid in vehicle validation. And that's it for data and sim.
Next, I want to invite the business systems to the stage.
Good afternoon, everyone. My name is Einar Ogle. I'm the sponsorship lead for Viking 67. I've been on the team for the past 3 years, and over the past 2 years, we've been really working to grow the business system. So I'd like to share a little bit about what we do on the sponsor subsystem. So we start off by looking at what the car needs. Is it funds to build, or is it CNC aluminum parts that we need to outsource, or is it something else that the team needs? And then we go into our outreach section, where we call, we email, and we produce media like our mid-season report and our sponsorship packet, and send that out to a variety of different companies, and also work within the school to secure funds and parts. And then finally, we like to shout out our sponsors, whether that be through logos on the car or on our media, whether that be Instagram or Facebook. And the one who runs all of that media is Buzz, and I'd like to pass it off to him to talk about that.
Hello everyone, I'm Buzz Westhuizing. I'm the media lead for Viking 67, and I've been on the team for about a year. To start off, we didn't have much of a media, we had some kind of a media system, but not much of an established one. So we created a robust one through strategic planning, production, and distribution, using channels that we had used and reviving some that hadn't been used for a while. Through this, we were able to communicate with students on campus as well as sponsors that we were trying to get to. Allowing this, we were able to build a better brand name for ourselves and promote ourselves, establishing us within the campus and the community of FSAE.
Hi everyone, my name is Caden Nebison and I am Shop Operations Lead. This is my 4th year on the team. So as Shop Operations Lead, it is my job to take away all the complications and add simplifications to our process in lab and in shop. What that really turns into is getting a lot of the tool trainings out of the way, so all the new members and the general members who are coming in and need to work on the projects that our leads need them to work on, they all need tool trainings on those machines that get those projects done. It is my job to get them through those and get them through those safely so that they can use those machines safely as they grow throughout the team. Outside of that, I'm a general lab tech inside the primary lab that we use, which gives me unique abilities around keeping lab open for fancy hours that we need to do certain projects, and also the ability to maintain our machines as they go down throughout our manufacturing process. Outside of that, I'm a general shop resource, which basically entails that I have a lot of experience on all of the machines, and I'm able to teach our new and general members how to do these projects and lead them through as they go into the next generation of the team.
And of course, none of this would be possible without our sponsors. Our sponsors are the reason that you see the car here today and a lot of the parts that are on the car. So a huge round of applause for them. And without further ado, I'd like to present Viking 67. It's my honor to show off this car for you guys today, and I'd like to invite you all up on stage. Feel free to ask any questions. Oh, and yeah, thank you guys all for coming out. We appreciate all your support.